Okay, so here we go. Let's try the next topic, which is expected value. So expected value, this crazy equation, what this equation just basically means is for any I going from 1 to whatever number you want, you take the outcome x and multiply it by the probability of that outcome occurring. Then you do plus, you take your next possible outcome and you multiply it by the probability of that one, and so on until you run out of possible outcomes. So in practice, it's actually a lot simpler than it actually sounds. So what you're doing here on an example like this, let's say you're given a table. So x represents your possible outcomes, 1, 2, 3, and 4. And then these probabilities right here give their corresponding possible outcomes. So notice here that the probabilities are not the same. So since expected value means basically the same thing as average, why is this different? Well, the reason why this is different than how you calculated average before is because this is giving weight to probabilities. Each of these outcomes is not equally weighted like you would assume when you do average, where you add everything up and divide by how many there are. So this is just a different formula to kind of compensate for the different probability weights. So using this formula, it says we need to take the first possible outcome, multiply it by its corresponding probability. So what we'll do is we'll make another column over here. It'll be x times the probability big X is equal to x. And so you're just going to take this number times this number, which is 0.2. This times this, 0.6, this times this, 0.3, and finally this times this, 1.6. And so at the end, you're just going to multiply, or add these up together. So 2 plus 6 is 8, plus 3 is 1.1, plus 1.6 is 2.7. And so this right here would be the expected value. But more important than the actual number is the actual understanding of this number. So the way you would say it if you're asked, what is the real world interpretation of this number? You would say, if this experiment was performed many, many times, on average, you can expect to get a result of 2.7 each time you perform this experiment. And so that would be the real world interpretation. So now let's go ahead and try another problem. Consider the experiment of tossing a fair coin 2 times. If we let H stand for head and T stand for a tail, then we can represent a sample space S for the experiment in the following way, as given. We assign to each outcome the number X of heads that occur in that outcome. Thus, for example, HT and TH are all assigned the number 1, HH is assigned the number 2, and TT is assigned the number 0. Compute the average number of heads for this data set. So I've written our sample space right here. And they said, let X represent the number of heads that appear on your 2-point flips. So even though there are 4 possibilities, you know that based off of this definition for X, there are actually only 3 X values. You can either get 0, 1, or 2. So you can only get these 3 possible outcomes for the number of heads that appear. So these are our X values. And now we need to find some corresponding probabilities to go with these things, the probability of X. So if we assume that this is a fair coin flip, the probability of getting this first heads right here is 50%. The probability of getting this first heads here is also 50%. So the same thing applies here. The probability of getting the first tails is 50%, the second one's also 50%. So what is the probability of getting 2 tails in a row? That's a little bit different. And the way you should solve this is you should take the TT would be the probability of the first, 0.5, times the probability of the second, 0.5, which is equal to 0.25. Most of you may look at this and you may say, well, oh, there's just one possible outcome out of these 4 possible outcomes. Yes, that works in this case, but that's a coincidence. If you were presented with a situation where you had an unfair coin, where if this was not 0.5 but actually 0.4, well, then your 1/4 doesn't work out anymore. So this is the actual proper way to do it. If the probabilities are equal, you can do the 1/4 thing if you would like, but this is the real way that you should learn how to do it. Is 0.5 times 0.5 gets you the possible outcome for these 2 events in a row. So this represents 0 heads, that's 0.25. So now for 1, there are 2 possible outcomes where we have 1 heads. So if we take this, HT, and we find this probability at 0.5 times 0.5 is equal to 0.25. and then you do the reverse, TH, you're also going to get the same outcome. So what is the probability of getting one head? Well, it's these two answers combined. You add these two together and you get 0.5. And then 2 is this result, 0.5 times 0.5, just like we did here. So this would be 0.25. And we know we're right because the sum of this column adds up to 1. If you found the probability of all the possible outcomes, then the sum of all those possible outcomes must equal 1. So now that we found the probabilities that need to go with each of these outcomes, we can find the expected value by taking the multiplication of each of these events. So 0 times this is 0, 1 times this is 0.5, and 2 times this is also 0.5. When you add these up together, you get 1. So again, what is the interpretation of this answer? If you were to perform this coin flip experiment many, many times, on average, you can expect to get one head on your 2 coin flips.